Hey guys, so today we're going to be working on standard 77, which is adding and subtracting radicals with like radicands. So remember, a radicand is going to be that number underneath the radical. So for example, on the cubed root of 27, my radicand is that 27. So in order to add and subtract, our radicands must be the same. So just like when I'm adding and subtracting monomials, if I had 4a plus 2a, we would go ahead and combine our coefficients 4 and 2 to get a 6a. So just like when we add and subtract monomial expressions, when our variables had to be the same, when I'm adding and subtracting radical expressions, let's say I had 4 square root 2 plus 2 square root 2, just like over here, I would add together my 4 and my 2 to get a 6, and then at the end I would still have my square root 2, so the radicand would not change. Let's go ahead and do example 1. We have 5 square root 2 plus 7 square root 2 minus 6 square root 2. So what I'm going to do is I'm going to go through and every radical expression that has the same radicand, I'm going to underline in red. So I have 5 square root 2 plus 7 square root 2 minus 6 square root 2. So now I'm going to take the numbers up front. 5 plus 7, that gives me 12, minus 6. So what I'll have is 6, and then I'm going to keep that square root 2. And once again, what we did is we added together this 5, positive 7, and negative 6 to get our 6 square root 2. Example 2. We have 10 square root 7 plus 5 square root 11 plus 4 square root 7 minus 6 square root 11. So this time we need to notice that we have two different radicands. We have a 7 and an 11. And so, like our rule tells us, to add or subtract radical expressions, the radicands must be the same. So if I go back to example 2, I can only add together those with the same radicand. So for example, I have a 10 square root 7 and a positive 4 square root 7. I can add together those coefficients to get a 14, and then I'll bring down my square root 7. Now I'm going to go ahead and look at the square root 11s. I have a positive 5 and minus 6. That's going to give me a negative 1. And then I'll have my square root 11. So just like in multiplication with variables, when I have that 1 in front, I don't need to have that there. So my final answer should be 14 square root 7 minus square root 11. Alright, so let's go on to example 3. Once again, we can only add and subtract radical expressions with like radicands. Well, when I look at my radicands on this example, none of these are the same. However, I can already tell that each of those has a perfect square in it that needs to be taken out. So if you get to a problem where none of your radicands are the same and they're not simplified, what we need to do first is we need to simplify our radicands all the way down to be sure that we can combine them. So what I went ahead and did is I went ahead and created my factor trees for all three of these expressions, or excuse me, all three, the square root 18, the square root 32, and the square root 72. So just like before, in order to simplify, I need to find my pairs. So in square root 18, I have a pair of 3's. In square root 32, I have a pair of 2's and another pair of 2's. In square root 72, I have a pair of 3's and a pair of 2's. So I'm going to go ahead and simplify this out. I bring out my pair and multiply it by the number in front. So I'll have a 6, and then whatever I don't have circled stays underneath my radical. Square root 2 for the first one. For the second one, I have a pair of 2's, so I'm going to have 2 times 2 times 2, which gives me 8. And I'm left over with just a 2, square root 2. And then for my last one, I'm going to bring out my 3 and 2, giving me a 6 on the outside. And then underneath is my last prime number, square root 2. Now what I see is that I have 3 terms with like radicands. So these can now be added together. So I'm going to take 6 plus 8 plus 6, which gives me 20. And then I bring my square root 2 with it. Alright, so here are your 3 U tries. Go go ahead and give them a shot. Bring your solutions and any questions you have to class tomorrow. Good luck.